So I want you to go to Google Sheet, and do you guys ever know how to use Google Sheet?
Yeah. Well, maybe. What's Google Sheets?
Or Excel, either Excel or whatever. How many of you guys know how to use Excel? Only two people? Three? Four? Five? Nobody is Excel certified?
Google Sheets. I think I prefer.
Nobody is Excel certified?
I was doing a course, but I got
You got bored?
my dad forced me to.
Actually, it's important. Like when you write, I don't know. Like now, I know like AI can generate Excel sheet now. It's pretty easy for them. All you guys tell them data, and they should be able to Excel sheet. But back,
I'm not gonna do that.
huh?
I'm not gonna use it.
Okay. So for this is I'm gonna show you how this actually work. So what we're gonna do is we're gonna talk about. Hold on a second. Quick time. I'm gonna talk about yesterday's thing. So get your notes out from yesterday, and then we keep a computer there. We're gonna talk about that. So we have a competition yesterday. Remember?
Oh, from our planet.
Okay. Okay. Oh my gosh.
Huh? How about the Texas dad?
That's cool. Bulbasaur.
I have his dad on a speed dial. Let me text him. Hold on a second before you arrive.
I guess so. Yeah, you're late. I'm sorry.
All right. So you are cutting off the corner, and this corner piece is this the corner, and every time I cut off, I'm gonna assign a variable, and this variable I'm gonna assign is whatever I cut off, I'm gonna cut off the x. Cameron actually did this perfectly at first, but he was thinking about x, but at first he was thinking about 21.65 minus x rather than minus 2x. I think your group helped you to say it's minus 2x. I think Josephine and Media told him says no, it's not just x, it's both sides. I think that's what you were saying, right? So so with kind of that group collectively, they are actually on a very, very good track. So if you think about this value, this is the x and x and x. Now, volume of this box is height times w times length. Now the height, if you fold it upwards, this becomes the x, would you say? Because you fold it up, this becomes, if you fold it from a crease like this, you fold it from a crease like this, if you fold a crease like this, if you fold a crease like this, that the height becomes an x. Does that make sense for everybody? Sydney, does that make sense? Both? Sydney? Okay. Carter? Okay. So that is becomes x. Is that okay? I replace the h with x. Now, what is the w? I forgot the length. I think it's 21.65, and I think it's 27.9, right? So, oh, sorry, this one is 27.9. This one's 21.65, I think, whatever. Okay, so then it's going to be x times the width is going to be 27.9 minus 2x. Is that okay? It's minus 2x because you fold it up, you subtract x on either side. And then 21.65 minus 2x. Is that okay? Is this okay for everybody? This becomes a volume equations. Now I'm gonna teach you something that, hey, look who's here. Hi. It's okay.
Wait, do we rent
I'm gonna set alarm. You guys should set alarm. Yeah.
Guys, if I try to drive myself to school today, so that takes an extra 20 minutes.
Wait, do we write this down in our notebooks?
Yes, yes. You write this on your notebook. So the volume becomes x times 27.9 minus 2x, 21.65 minus 2x. I think only Amelia's group and Cameron and Josephine, you guys come up with an equation that is very similar to this. I think it was architected by Cameron, and then Amelia and Josephine kind of told him, says, no, it's not x, it's 2x rather than just x. Okay, so is this okay to understand the volume equation? Now, what we're gonna do is we're gonna actually teach you how to use numbers. So you're gonna open up Google Numbers. I'm gonna use Excel because I prefer Excel. And I'm gonna teach you a little bit how to use Excel. The x, the height is x, right? So with the x is adjustable. So we're gonna say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, do I really want to type in each width? That's the problem. I don't want to type each width. So there is a way to do it so I don't have to type each different width. Okay, there's a way to do it. So you're going to go to the width cell. So this is called a cell, by the way. A cell like right here, we're going to replace the height, width, length, volume, and we're going to tell you all this data. So when you're writing science report, like lab report, when you go into college, you need to learn how to use Excel. And here's how to use it. I'm going to teach you right now. So you don't want to type in each width. You want to use computer to generate that for you. But how would I do that? So you're going to type in this equation. So you're going to say equal to, this cell width is equal to, well, width is equal to 27.9 minus 2 times the x. X is 1, but that's not always 1, right? So we're going to use the cell C2. So you're going to type in C2, or you can click on here. They'll type in the C2 for you. And you're going to press enter, and they're going to get 25.9. Okay, and you're gonna do the same thing. So, but you need to do that same thing for all of them. But then you say, wait, I could have just typed in like 25.9, 23.9, 21.9, like that. But here's a trick. The trick is using not white Jesus, it's a black Jesus. And I'm gonna tell you why Jesus. Do you see that cursor? It's a white. Right? White cursor, right? So you move it in the cell, move to the cell, move to the corner until they turn black. Do you see that black? Do you see that? Then you just gonna, when they turn black, just drag it down. So black Jesus, yes. I type in, for me, like I using, I use the cell here, so I just use the 27.9 minus 2 times, and I click the cell C1 or C2 because when I click to it, that's my cell that assigned the height. Okay, so I'm gonna do that again. I'm gonna type in equal sign 27.9, which is that's the width, minus 2 times, and click on this. Click on this cell, C2. So, or whatever cell is for your sheet, right? Whatever it is. And then you click on this, you turn from a white Jesus to black Jesus right here. If you see that cell, white, black. And you're going to drag it down, and it will get all the value for you. And you're going to do the same thing for the other one, equal to, I'm going to do that again, is equal to 21.65, right? Minus 2 shift 8 times. Are you following me so far? and click on the cell of the height. Click on this cell. Whatever cell you use is gonna be whatever you think. So I'm gonna click on the height cell, C2. Now for me, the C2. For you, is maybe A2. For other people, maybe D2. But I click the cell of the height. Now I press enter here. I got 19.65. White Jesus, black Jesus. You're gonna go down. And you're gonna get all the data at the same time. That means you didn't use the correct. This C2, you did not use correct. You're gonna have to use the one that you assigned. So in this particular case,
Oh, you should have asked me.
Oh, curious.
Yeah. By that one, you were close on
It said identify any outliers in height. I didn't know I was gonna pop.
all right. Shh. Now I can do the volume. How do I do the volume? Volume is equal to what? So equal to, I'm gonna click on the first cell and then shift A to the second cell, shift A to the third cell, and I'm gonna press enter. And then this is how you write a good lab report, like because you can generate all the data at the same time, and that's your value. Does that make sense?
Yep.
Okay, so now you can actually take, yes, because you probably used the wrong thing. Okay, so now I can take this data. I'm gonna highlight those data. So this data, I'm gonna highlight it, and I'm gonna go insert. I'm gonna click insert, and I'm looking for a specific thing. Hold on, I'm gonna looking for this one here. There's a X at, it's like a dotted plot. It's called scatter plot. So you type in the scatter plot like this, and you want the one that connecting. So this gonna form like this, and this is gonna tell you that this table with the certain height, roughly at 4 point something. It's 4.137, by the way, to be exact. But at 4, it's gonna give you. So this is gonna tell you all the data points, like whatever you cut off, and that's gonna give you a height, the volume. Okay.
What'd you press for that again?
What?
What'd you press for that again?
Wait, what chart do you?
Okay, I click the highlight of this chart,
Yeah.
right?
Yeah.
And I type in insert, and there is a one that looks like this, a dotted with a coordinate, XY coordinate dot. And when I click on this, it should show up like this one. You don't want to scatter, you want to scatter with smooth lines, markers.
Oh, like this.
And then that's gonna give you the volume versus the height. Yes. So that's some general things. I'm usually helping a lot of my students to do different things, so that way they, in the future, you can actually use those. But right now, this is gonna tell me like, hey, what happened to value? If I cut out 1 centimeter, if I cut out 2 centimeter, if I cut out 3 centimeter, cut out 4 centimeter, this is gonna give you a certain height here, estimations. So it's gonna be the cutoff versus the height. Now, this is not what I'm trying to do because I could have used this on Desmos, which is a little bit faster because Desmos is gonna give me better answers. So we're gonna shrink this, and we're gonna this. We're gonna do a here, left, and right. Guys, this is the part that after Cameron take a test, I'm gonna issue your last test home, and you can go back, figure out if something you did wrong, because I want you. That's why I want people to take it on the test on the test day, so I can issue the actual test back. Have you taken it? You've already taken the test already, right? Nobody missed a test? Okay. So I'm gonna issue that back. Let you look at it and then see, like empty test, let you work through with the friends and see if you can actually start figure out how to do mean value theorem. How many of you guys didn't know how to do mean value theorem on the test? Okay, well you did come back after school try to work it out, right, Max? Okay, good. Okay, so with that being said, now I'm gonna type in the equation v of x on decimals. Yeah, on decimals now is equal to x. Now, guys, try it right now. Get the decimals out and try to use this because you gotta use the decimals on the actual AP exam, and you gotta learn how to use it, and you have to learn how to extrapolate the data. Okay, so 27.9 minus 2x and times by 21.65 minus 2x, and that's this. I'm gonna press enter. So I'm gonna press home right now. This is what I see. This is what you guys see, right?
Yeah.
Now this is a problem. Is when you see this, you don't know what to do with it. Now I'm gonna talk about one more thing. I'm gonna go back here. I'm gonna say, in terms of math, that there is something called physical domain. Now in terms of math, there is an actual domain of the function. But in here, as an engineer, because I teach, remember I told you I teach a group of 7th grader how to do calculus in the summer? And there's one person named Professor Wang, and he's a civil engineer professor in UCF. And I didn't know, I was teaching them calculus, and then this guy come up to the front and says, hey, I would like to tell you something, you missed something on your calculus. And I was like, shit, what did I miss? And he's like, you missed something that's very important. It's called physical domain. You understand your math domain, but there is something called physical domain. The physical domain is that piece paper. It has some type of restriction. And the only one person that named that is actually Cameron. Okay? But his physical domain is slightly off. I'm going to talk about why it's slightly off. It's equal to 21.65 minus 2x rather than minus x is equal to 0. So the x equal to 10.825. So that means that it was 0 less than x less than 10.825 is your physical domain. What do you mean by physical domain? That means your paper cannot cut more than 10.825. If you cut more 8.35, that means you cut off right here and you cut off right here. You're not going to be able to form a box at all. You cannot form a box because you cut off the short end, you cut off the maximum value, maximum length, and you cannot form the rectangular prism anymore. So that's called a physical domain. So luckily this professor come up to the board and he teach me something about engineering, because engineering, you only have a certain amount of material. You don't have infinite amount of material to build a train track, right? You don't have all the material in the world. You don't want to build a train track in circles. That's not optimized. You want to build from one point to the other point in the straightest possible lines. That's called optimization. But sometimes if you build on top of water, it's more expensive. So you got to go around the water. So that's also optimization because of the cost. You want to make sure the trains don't go through the lake. You had to go to on the land because it's expensive to build on the lake rather than on land. Those are engineers have to think about. And those are the things I did not think about as a math person. So he told me it's a 0 to 10.825. That is your physical domain. Is that okay? Mm-hmm. Now, what happened here, I'm going to drag it here. I'm going to say, well, I see a straight line. So what the hell does that mean? That means this. I can click on the wrench, and I know I don't need a -10 because I don't cut off negative values. So I cut off from 0 to, between 0 to, my bad, between 0 to 11. Is that okay? And now I see two lines. I see a line here. I don't see a line here, so I like to cut off that maybe says -1 to 11. Now we know the volume. According to the Excel, the volume we can get as high as 1086. So we need to change the Y output to 1086. But You want it bigger than that. So that says 1100. So now we see this peak here. It's at 4.03177. And that is the maximum cutoff I can do, right? I can do in terms of this. Now, I'm going to open up this graph just slightly a little bit more because I want you to see a different part of the graph. I want you to see all the way to 20. I want to see 20 here, and I want you to zoom out a little bit. I want you to see those two peak situations. Now, remember on your tests, a lot of people did it wrong. So I'm going to highlight this. Do you see? I'm going to highlight this. This is the volume equation. But I'm going to type in v prime of x. That's the derivative function. Because on your test, I give you the derivative function. I asked you, remember I asked you which part's increasing on original function. Do you know from what value to what value is increasing? From where? Samantha, from where to where is increasing? Amelia?
Negative infinity to 12.3, and then from 12.484.
Yeah.
Oh, okay.
Because it's above x-axis. This is the v prime of x. Yesterday's test, or Friday's test, is the f prime of x. F prime of x, you look at the positive region. You're supposed to do a number line. You're supposed to do a number line. Anything above the x-axis is the original function is increasing. Is that okay? And this becomes the maximum. Now look at this part of the graph. This is decreasing because of below x-axis, right? And this is above x-axis. Look at original graph. See if that's true. 4.03. 4.03. Because this above x-axis, original function is increasing. Do you see that? Look at here, from here to here. Oops. From here to here is 12.075. 12.75 from here to here. Look at all this point. Exactly matching. 4.30317 to here is all decreasing, and after that is increasing. Do you see that? It's a very like understanding. Now everything should clicking. Hopefully everything should clicking. Does that make sense? Do you see there's a maximum here? This point here? That's the maximum. The original function is the maximum. Do you see that? That's a comparison. Now, I want to show you one more thing. Look at the concavity. See, from this point, where's the concave down? From what point to what point is concave down? Original function. Concave down is from where to where? Concave down is from where to where? Where's the inflection point happen? Yes, Amelia? Yep. See that it's decreasing? It's decreasing is concave down because decreasing is the slope of f prime. So that is concave down and that's concave up. That makes 8.25 is a what? Inflection point. Look at if it's true. At 8.25, this is x equal to 8.25. Do you see that's, oops, y? No, x equal to, like this. Do you see at that point it's an inflection point? At where the green line intersects the red line, it went from concave down to concave up. Do you guys see that? Okay, now one more thing I want to talk about is the second derivative. Second derivative test. Now I'm going to look at this. Look at this here, 4.037. That is horizontal tangent because that slope is equal to 0. Are you following me? Look at the second derivative. Is negative or positive? Second derivative line, the purple line is negative or positive at 4.037. Negative. So it's concave down. Therefore, original function is what? Maximum. Remember those one question like that at the end? It was to give you a value and you had to figure out are they maximum or minimum or inflection point? It was a maximum or a minimum at a particular cases. But look at this point here. Is concave up because it's positive. It's also horizontal tangent. Then it's gonna create a minimum situation. Everything still come back. Everything's clicking now, hopefully. Now we have built this connection for all of them, and you are starting to understand, oh, okay, this is what we learned throughout the whole chapter, because we can analyze this graph. I can take this graph. Yesterday, I just have to be able to name this equation on decimal. I put on V prime. I can see everything. I can see everything. I don't need those fancy stuff. I can see everything going on. Now, is that okay to make sense for this question? Okay, so this is the first lesson of optimization. We're gonna go to a harder questions today. So today we're gonna introduce you new questions. So how much time I have?
12 minutes.
Good, that's enough time. So I'm gonna close this part. Leave page, and I'm gonna open this. Okay. So remember, I'm a manufacturer, if I'm a packaging company, packaging company is, I'm trying to like increase my profit. But how do I increase my profit? How do I increase my profit? This is a very easy economic cost. Anybody taking economic right now? Okay, how do I increase my profit? You decrease the cost, increase the revenue, right? Because the revenue minus the cost. How much you sell? Let's just say if I sell this iPhone for $1,000, I want to sell as many iPhones as possible. That's increasing revenue, right? But I also can do increase, in order to increase profit, I actually can decrease the cost of manufacturing the iPhone. So today we have a situation. We have a manufacturer want to designing a open top box. Open top box. So we don't need a top. We don't need the top. We just open top box, just like what we did before. But this one, I'm gonna require a square with having square base. So this box has to be a square base. Okay, so is this a square base?
No.
No, this is a rectangular base. But you're gonna see, imagine that this shape's all the way here, that this is square base. Is that okay? So this is more closer to square base than the other one, but it's still rectangular. This is a almost square base. Almost. Okay, almost. This is a rectangular base. So square base, that means the base has to be a square. Okay? So, and the surface area, which is, I want to minimize the cost. I want my surface area to be exactly equal to 108 centimeter squared. So I want it to have 108. So the question says, what dimension of a box will produce maximum volume? VOLUME, maximum volume. So here's my question. What are we trying to maximize? Are we maximize the surface area, or we maximize the length? We maximize what? What do we maximize? Volume. So obviously we need a volume equation. But before that, draw pictures. Picture means a lot of time underestimate drawing picture. Most of you guys doing SAT, if you realize all the geometry question, they do not give you a picture anymore. They say a triangle ABC is similar to DEF, and the triangle ABC is a right triangle. So you're gonna have to draw ABC is a right triangle. And they will say angle B is 90 degrees, and you're gonna have to label B is 90 degrees. Now the SAT question, they don't give you pictures. If you realize that, they want you to draw it. Drawing a picture is just as important to solving the problem. So now I'm gonna draw a picture with a rectangular base. So this is a rectangular base. Sorry, that was really bad. Let me do it again. Okay, rectangular base. So now the next thing is assign variables. According to the spec, right? What was a spec? Square base, what's that mean? The bottom part of this length here has to be equal to this length. Is that okay? Can I just assign them as x times x? I like to use it x, right? So I don't need a x. We know the volume is equal to length, width times height. But here, we're gonna say the bottom is gonna be the square base. So it has to be x times the height. So it's equal to x squared h. But if I were to take a derivative, I need a product rule. And I'm not a big fan of product rule. So were you. Because yesterday, on one of the finding absolute maximum, you have to do a product rule, I think. Right? One of them you had to do a product rule.
Shoot.
I feel like there's one of them you had to do a product rule. Or that's just chain rule. It's the square root of 1 minus x squared. Just chain rule?
Crap. Okay.
Okay, no, there's no product rule. Don't worry about it. So we want to avoid the product rule. So, hey, what if this w, x and h are the same variables? Then we can do that. But so we're gonna call this one is volume equal to x squared h. Is called a primary equation. What do you mean by primary? Primary is what we're trying to optimize. We're trying to optimize the primary equation. Now, we need a secondary equation. But what's other information that we got in secondary information? Surface area. So let's think about surface area. So surface area is equal to 108. But we can say 108 is equal to surface area. How do I figure out the surface area of the square box? Look at it. Is the bottom, right? Bottom area, right? Plus the lateral area. Lateral is the side. Not the top. I don't need the top. How do you find the bottom area? How do I find the bottom area according to assigned variables? X times x squared. Is that okay? How do I find the lateral area? X times h, but how many times? 4xh because it has 1, 2, 3, 4. 4 sides. Right? Is that okay? Now this is known as the secondary equation. Is that okay? This is the primary. Now this is what we're trying to optimize. We're trying to optimize this. Then you say, okay, what if I change the x in terms of x? How do I do that? Look at the secondary equation. Because this one can help you reduce the variable. Because this one has one extra information, which is the area. So how do I reduce the variable? I want to reduce the variable for h. Why? Because that's the easiest one to solve. So it'd be 108 minus x squared equal to 4xh. Am I going too fast? Can I solve for h? 108 minus x squared over 4x is equal to h. Now, I'm going to go to the primary. Primary says x squared h. So b equal to x squared times 108 minus x squared over 4x. Is that okay? I didn't do anything crazy. I'm just doing basic math. I just substitute h, just like what we're doing with the cone. We have one similar triangle. We can reduce a variable into just all in terms of h. The same thing we're doing here. Now we want to find the maximum value. We had to take a derivative, right? So, but before we take a derivative, I can distribute this. I can simplify this square and this h. And this is going to be 108x over 4. Minus x third over 4. I can split them. If I can distribute, I can split them, right? This is equal to 27x minus x3 over 4. Now, I become a volume equation. Now, we're doing what we know. If you don't know anything in calculus, take a derivative, set it equal to 0, you find something. That means something. Let's just say you are stupidest person, take a derivative, set it equal to 0, you find something. Okay, I'm going to take a derivative. Set it equal to 0 because that's a critical number. So 27 equal to 3/4 x squared. I times by 4 on both sides. I can plug in the 6 back into this equation all the way to here. So it'll be 108 equal to 6 squared plus 4 times 6 times h. Yeah, 72 equal to 24, h is equal to 3. So it's to be 3 times 6 times 6, or 6 times 6 by 3.
Isn't the 27 negative?
No, you're gonna move to the other side so it's positive.
Oh, I see.
So this is a box. Cameron, make sure you do your work. You have the highest potential for us engineer thinking ability, but your math suck.
I have to work on that.
Okay. Your math so bad that it's hurting your capability.
Is there any way I can get the first related rates test in Skyward? Because I think I got like 20 points higher on it, and it's like I don't want to have like an F class.
I'll look at it. I want to look at your old school. I didn't see it.
It wasn't great.
Why don't you do better?
I don't know. I thought the retake was after school, so I didn't study as much as I should have.
Okay.
I think Monday's test didn't go too bad though. I don't know.
I'll see you after school.
Okay. Oh, I didn't even record it, did I? Huh? Yeah, but look at this. It's not like.
Only part.